In this work, we propose Affective image filter, reflecting emotions from text to images. We will elaborate on the following 4 parts. The first part, Introduction. We propose Affective image filter, a novel model that is able to understand the visually abstract emotions from the text and reflect them to visually concrete images with appropriate colors and textures. The desired properties of a well-qualified AIF algorithm are outlined, which demonstrates AIF's advantages if the following 3 objectives are met: emotional fidelity, content consistency, and controllable synthesis. Compared to image style transfer methods, which generate images based on visually concrete colors and textures from a reference, AIF algorithm aims to understand visually abstract emotions from text and images. Next, let's delve into the second part, the dataset. We manually create a specialized dataset for AIF. Existing dataset aren't suitable for AIF due to, first, focusing on image content rather than emotions. Second, excessive color and texture words. The right half displays the qualified dataset. Now, let's move on to the third part, the pipeline. We build our model based on the multimodal transformer architecture, which unifies both images and texts into tokens and encodes the emotional prior knowledge. Various loss functions are proposed to understand complex emotions and produce appropriate visualization. First, we select positive, related, and negative text descriptions for each seed text description from the AIF dataset using similarity lists and use them as inputs. Next, we encode the text and images separately, input the encoded tokens into a multimodal transformer, and then obtain the generated image through the decoder. Finally, we train the model to understand abstract emotions in user texts and create appealing images that evoke emotional responses. We define the sentiment vector by concatenating elements and the sentiment vector by concatenating elements. As a result, the AIF model learns relationships between emotions in a metric learning manner and proposes sentiment metric loss. We further design the emotional distribution loss to estimate the distribution of emotions. We pre-train a distribution estimator and use the Kullback-Leibler loss to measure the information loss caused by the inconsistency between the estimated distribution and the ground truth. Finally, let's delve into the fourth part, the results. Our method well preserves the original visual content, synthesizes appropriate colors and textures, evokes specific emotional responses from human observers, and reflects visually abstract emotions more accurately. We discard various modules and create 4 baselines to study the impact of our proposed modules and designed losses. Here are the evaluation scores and synthesized images from the ablation study. Our model can be used on social platforms such as Twitter and WeChat. When users input text and corresponding images to express their emotions and personalize their content, the platform could offer candidate images in real time that reflect their emotions, thereby helping them stand out from the crowd and attract more followers.